Hi everyone. So clocks are the heartbeat of the design. In today's video, I'll walk you through the different methods of generate clocks effectively. So stick around and by end of this video, you will have a solid grasp of various techniques you can use in your project. So let's start. So we will see these four methods using repeat, using always block, using forever loop, and we are using the parameterized clock period. So let's start. So I'll start with the module. I'm giving the name as clock generation. Here I'm not passing anything. I'm keeping it void type. So we are going to use four clock generation methods. I'll define four clocks. I'll give them name as 1, 2, 3, 4. Okay, so let's start with the first one, which is a repeat method. So first of all, I'll take clock 1 for this one. So since this clock 1, 2, 3, 4 are the register type, so by default their values are unknown. So first of all, I will set their value to 0. You can set it to 0 or 1, anything. So now I'm using this repeat loop and I am giving the repeat of, let's say, 6 times. After that, I'm giving some time unit delay. I'm taking here 5. Okay, so here what we are doing. So this is the clock register. So first of all, at t equal to 0, I'm assigning this a 0 value. Now I'm calling this repeat and I'm repeating it 6 times. Means this line will execute only for 6 times. And what we are doing here, after 5 time unit delay, we are toggling that clock. So this is how you can use repeat method to generate the clock. Here the clock will toggle only for the 6 time. Now coming next to the always block, always block method. So again, this is the register. So I will define this initial value. Okay, it's this time I'm giving it one. It's fine. You can use anything. Same thing. Okay, let's say this time I'm giving time delay of 6. You can use any time as per your requirement. You can use the delay. Coming next to the forever. Now forever also works same as the always. So you can give some delay of 10. Then Okay, so here you can see every time we are giving some number which represent the delay. I mean, at what time you want to keep your clock low and clock high. Now, let's say you are you have declared somewhere the clock and you want to change the clock period. So what you can do, you can use the parameterized method. So for that, you can define the parameter here. Let's say I'm giving the clock period equal to, let's say I'm giving 10. Okay. Now this also works same, but here instead of giving number, you can use that parameter and you can use it like this. So here I'm using this clock 4 instead of clock 3, so I'm changing the name. That's it, and module. Now whenever you write in this way using forever and always, so what happen, uh, tool will start reading all this initial line at t equal to 0. Next, at t equal to 0, it will see the register value. Here, everywhere I set it some value because these registers are by default, they have unknown values. So I'm giving some value to start. Next, here in this case, this clock will be read, this tool will read this line for 6 times and then it will come out from this initial block. But here in this case, once this pointer will come here, it will always stay here. Same goes for this and same goes for this for forever. So to end the simulation, we will use $finish here. So I'm adding $finish here. So let's say I'm using 100 time unit delay and using $finish. Okay. And to generate dump, you can use this $dump as and $dump file dump dot vcd. Yeah, so these are the 4 ways you can generate the clocks. Now let's set the configuration. So okay, language is Verilog SystemVerilog. Here tool I'm using this LDAC. So see here compiler option is there, compiler directive is there. So tick timescale 1 nanosecond with 1 nanosecond precision. So now all this time units, whatever we have defined here, will take the time unit as a nanosecond. So all the delays are now in nanosecond. Let's run. Okay, let's stick the CP wave. Run. It's clear. Okay. So you can see. So first one was the repeat one. So here you can see we gave repeat 6. So it will toggle for 6 times 1, 2, 3, 4, 5, 6, and then it will come out from that loop. Second case was always, and we set the clock to initially at 1. So it will be at 1 and at every 6 nanosecond it will toggle. So you will see 6, 12, 18 toggling will come. Then comes to this one, clock 3, we use the forever loop and we gave the delay of 10. So every 10 nanosecond it will be toggling. So here you can see the time unit nanosecond, 20 nanosecond. Same goes for the clock 4. So using this parameterized method, it will give you the advantage. Let's say you want to change the time period to 20. So instead of going and changing there, you can just change it here. You can run it again. Your time period will change to 20. So you can see now this two have time period of 20. So this clock has time period of 20. I hope you understand the clock generation methods. Thanks.